we are going to discuss an improper integral where there is an vertical asymptote within the range of the integration. In this example, the function to be integrated is 1 over x minus 1 to the power of 2 thirds. And the range of integrations is from 0 to 3. The integrand function, which I represented with fx, can be represented on the xy plane. Here we indicate the vertical asymptote at x equals to 1, and the integrations is to be performed from x equals to 0 to x equals to 3. So obviously the integration from 0 to 3 should cut through the vertical asymptote at x equals to 1. When x is exactly equals to 1, the function will tend towards positive infinity. Here we indicate the asymptote, and the function is going to positive infinity from the left as well as from the right. Specifically, if you consider a point, let us call A, which is lying on the left of x equals to 1, and if A is approaching 1 from the left, the function is going to infinity. Likewise, if you consider a point called, say, C, where C is lying on the right of x equals to 1, and if C is approaching x equals to 1 from the right, the function is also going to infinity. The improper integrations from 0 to 3 represents the area under the curve of the function f bounded between x equals to 0 and x equals to 3. So roughly it is represented by the shaded area in yellow. The area under the curve being considered, which is equals to the improper integration, is it finite or is it infinite? This is the questions we are going to answer in this video. To proceed with the improper integration, we first break the integration into two parts. The parts that involve the integrations from 0 to 1 and the parts of the integration that involve the right hand side of x equals to 1. The left hand side of the area is written as 0 to 1, whereas the area under the curve on the right hand side of x equals to 1 is represented by the integrations from 1 to 3. At x equals to 1, the function fx is not defined. Therefore, we're going to replace x equals to 1 by an values of a, which is very close to 1 but never equals to 1 on both of the two integrations. For the integrations on the left, we are going to replace the values of 1 by a, where a is assumed to be a number which is approaching x equals to 1 from the left, but a itself would never be equals to 1. The integration from 0 to 1 is then evaluated as the limit of this proper integration when a is tending towards 1. For the integrations involving the right hand side of the area, the limit of 1 is replaced by the values of c which is larger than 1 but never be 1. We represent this with integrations from c to 3, and then these integrations is to be taken as the proper integration with a lower limit c, and c is tending towards 1 from the right. I think I made a mistake of the notations here. We should refer to the limit of a tends towards 1 from the left. Therefore, this should not be 1 plus but with 1 minus to indicate that a is tending 1 from the left. To proceed with these integrations, we first define the capital function f as the indefinite integrations of the small function f, which is just the integrations of dx over 1 minus x raised to the power of 2 thirds. And this is simply evaluated to be x minus 1 to the power of 1 third with a factor of 3 plus n constant. In terms of the capital function f, the integration that involves the left hand side of the area, which is this part, can be written as the difference between capital function f at a minus f at 0. F of a is simply equals to 3 times a minus 1 to the power of 1 third, whereas f at 0 is simply equals to 3 times minus 1 to the power of 1/3. And this is simplified to 3a minus 1 1/3 plus 3. We take note of the fact that minus 1 to 1/3 is simply minus 1. So this is just this. The limit of the integrations on the left hand side with a going to 1 from the left is then simply the limit of a going to 1 from the left for the expression 3 times a minus 1 to the power 1/3 plus 3. And this is just simply equals to 3 because a minus 1 will tend towards 0 when a tends towards 1. We then look at the integration on the right hand side of x equals to 1. The integration is from c to 3, and this is just the function of f evaluated at 3 minus f evaluated at c. So f at 3 is simply 3 times 3 minus 1 to the power of 1/3, where we are replacing x equals to 3 in this expression. F at c is simply this expression with x replaced by c. So this gives us the integration on the right hand side of the area. The limit of the right hand side of the area when c tends towards 1 from the right is then simply limit of 1 going to 1 from the right for the expression of 3 times 2 to the power of 1/3 minus 3 times c minus half to the 1/3. And it is obvious that when c tends towards 1, the factor of c minus 1 is going to vanish. So this term is going to be 0 when c tends towards 1. So what is left is just the factor of 3 times 2 to the power of 1/3. So up to this point, we have arrived at the result that the limit of the integration on the left hand side of the area is 3, whereas the integration of the area on the right hand side of the curve is this. Putting both together, the integrations of the integrand from 0 to 3, which is the sum of the limit a going to 1 from the left from 0 to a, plus the limit of the integration for c going to 1 from the right is simply equals to 3 plus 3 times 2 to the power of 1/3. That is the result of this improper integration. As a conclusion, we have discussed the improper integration of this integrand, where the range of integration is from 0 to 3, and there is an vertical asymptote x equals to 1 sitting in the middle of the range of integration. The improper integrations hence has to be broken into the left-hand side and the right-hand side. The left-hand side is written as the integration from 0 to 1. The right-hand side integrations is written as the integration from 1 to 3. There is an vertical asymptote or infinity for the integrand at x equals to 1. Therefore, we have to replace the upper limit of 1 by a for the case of the area on the left, whereas the lower limit of 1 appears for the area on the right hand side of the integration by c. Here, c is a number which is larger than 1, whereas a is a number which is on the left hand side of 1, but a would never be exactly 1. We have obtained the indefinite integral in terms of the capital function f. With this result, we can then express the proper integrations in terms of a as this expression. We then take the limit of a goes to 1 to arrive at 3. This would then represent the area of the integration for the left-hand side of the area. The right-hand side integration is given by this, which turns out to be the limit of the integrand involving the c term, where we take c goes to 1 from the right. The limit of this term is then shown to be 3 times 2 to the power of 1/3. Therefore, the total area of this integrand is just a sum of the integration from the left and the integration on the right. And that turns out to be just 3 and 3 times 2 to the power of 1/3 respectively. So this is the convergent value for the improper integrations of this function from 0 to 3.